So what are rational numbers? Now, we have already looked at natural numbers. Natural numbers are the numbers that start from 1, because that's how we start naturally counting. We start naturally counting from 1. So the numbers that start from 1, 2, 3, 4, and so on, they are natural numbers. They extend up to infinity. Then the next type of numbers that we learned are whole numbers, and you get a whole number just by adding a 0 to the natural numbers. So the whole numbers start from 0, 1, 2, 3, and so on up to infinity. Then we also learned about integers. So what integers do is that we understand that there are some numbers known as negative numbers, right? So integers introduce the concept of negative numbers. So numbers on the left hand side of the 0 on a number line, these are all negative numbers, and the numbers on the right hand side of the 0, they are all the positive numbers. Now these two numbers together, the positive numbers and the negatives along with the 0, they are known as integers. Now if we look at the natural numbers, the whole numbers, and the integers, you can see that the distance between two consecutive numbers is 1 unit. It could be a unit distance, for example 1 centimeter, whatever, but it is essentially the difference between two consecutive numbers is 1, always. Now when we come into the idea of rational numbers, is it possible to have numbers between the unity? So for example, between two numbers, that is 0 and 1, or 1 and 2, or 2 and 3, are there any numbers between them? And we actually do have those numbers, and those numbers are what we call as rational numbers. Now you can see here that what we have done, we have this number line where we initially we had 0, 1, and 2. Now what we have done over here is that the distance between 0 and 1 is divided into half, and we have used a number half to represent this point on the number line. Similarly, the midway distance between 1 and 2 is represented by this number over here, 3 by 2. And the same thing we can apply on the left hand side of the 0 in this direction, and you can see that we have minus of half and minus of 3 by 2. So you can see that the numbers that lie between the full numbers like 0 and 1, right, these are the rational numbers. So how do we represent rational numbers? So it turns out that there is a general representation of rational numbers. So all we do is the rational numbers are represented in the form of p by q. So any number which is in the form of p by q, where q is not equal to 0. Now you are already aware of these type of numbers. Fractions, for example, are rational numbers. So the number on the top is known as a numerator. So in this case, p is a numerator, and the number below is known as the denominator. So q is a denominator. And the key condition for rational numbers is that the q must not be equal to 0. The denominator should not be equal to 0. And as I mentioned earlier, fractions, for example, are rational numbers. So all these numbers, 1 by 2, 3 by 2, 5 by 2, proper and improper fractions, when represented in the form of p by q, where your denominator is not equal to 0, that is q not equal to 0, they are rational numbers. An important thing to remember: how do we represent the rational numbers? Okay, so now let us look at a couple of examples of how we can find some rational numbers between any two given numbers. And we'll look at a couple of cases. So let us look at the first example. Now we are asked here, find any three rational numbers between the numbers -2 and 0. Now -2 and 0 are rational numbers. So what do we do is we try to convert both of these numbers into numbers with same denominators. And again, this denominator just tells you how much you are dividing the distance from 0 to 1 and 2, or a unit distance on the number line. So in this case, since we are asked only three rational numbers, I can divide it into, let us say, 10. Now the reason why we take 10, because it's very simple, right? It's easier to divide it into 10 parts. So let's say minus 2 is multiplied by 10, both the numerators and denominators. Now remember that minus 2 is actually minus 2 by 1. It can be written as it. So when I multiply both of them by 10, we get minus 20 by 10. Okay, these are same. And 0 can be written as 0 by 10, right? It still gives the 0. So what we have done is we have converted minus 2 and 0 into two rational numbers with same denominators. Of course, they were having minus 1, but we just changed the denominator so that we can have some more divisions. Now it's very straightforward. You can work from minus 20 by 10. So what do you have? Now if you try to visualize this a little bit, we are, let us say that this is minus 1, and let's say this is 0, and we also have minus 2 over here. So what we have done is these parts have been divided into 10 equal parts, these unit distances over here. Okay, and the minus 2 here is actually minus 20 by 10. So the next point here is going to be minus 19 by 10. So you actually have about 18 numbers to select from, right? So you have minus 19 by 10, minus 18 by 10, minus 17 by 10, and so on. So you could pick up any three numbers, for example, these three or any of the three that you like. So this was one approach of finding out three rational numbers between, or finding some rational numbers between any two given numbers. Now let us look at another example. Find out any 10 rational numbers between minus 5 by 6 and plus 5 by 8. Okay, so this sounds interesting because what we have over here is the denominators are different for both the rational numbers. Now, a very simple and straightforward way to work this out is to convert both of these numbers to the same denominator. That is the first and the crucial step to remember. So what we do is we just find out the LCM of 6 and 8. Okay, and you try to, why do we take LCM? Because that will give you the smallest denominator for these two numbers. So in this case it will be 24, and what we do is minus 5 by 6 multiplied by 4 by 4, so we get 20 by 24. And similarly, if we want to make the denominator of the other number 5 by 8 as the denominator is 24, so we again multiplied by 3 by 3, so we get 15 by 24. Okay, now if we, so what we have, so we have to now find out numbers between minus 20 by 24 and plus of 15 by 24. So what is the intuitive feeling? If you remember representing the numbers on a rational numbers on a number line, so we have divided a unit distance on the number line into 24 equal parts, or we have just divided unity, okay, the unity into 24 parts. So now you can see there are so many numbers available, and you can just pick up any 10 numbers here. And in this case, what I have taken is minus 19 by 24, minus 18 by 24, and you can go all the way up to 14 by 24. Any numbers, any 10 numbers, they are perfectly valid. So to kind of conclude our discussion on finding rational numbers between two rational numbers, if there are same denominators, the first case we saw, you try to convert it in such a way that you can get some more numbers. Like usually we try to use multiples of 10 just because it's easier to calculate and get the numbers. In the other case, what we had a look as, if we have different denominators, all we try to do is try to convert to the same denominator, and then the problem is simple. Pick up any of the numbers of your liking between the numbers that have same denominators. So that was about finding out rational numbers between two given numbers. And in the next video, we will look at another important method to find out rational numbers between any two given numbers. That method is known as the mean method. Okay, so let us look at how do we represent the rational numbers on a number line. Now, if you remember how we used to represent fractions on a number line, it is similar to that. I mean, a rational number, for example, a fraction is a rational number. So let's begin with a very simple rational number, that is 1/2, and we want to represent this number 1/2 on a number line. So what we do is very simple. Between the points 0 and 1 on a on a number line, we divide this distance in two equal parts. Now, if you remember, this 1/2 is a fraction, and a fraction simply says parts of a whole. So when I say represent 1/2, it means represent one part out of two parts. Okay, and in this case, this midpoint that is shown over here, this point over here represents the one part out of these two parts into which one has been divided, and therefore the 1/2, this point here just shows 1/2. So this is how we represent 1/2 or 1/2 on a number line. Now remember, the 1 can be written as 2/2. Essentially all we are saying is two parts out of two parts, that is one part, this unity here, the distance from here to here between 0 to 1 is divided into two equal parts. Now you can extend the same logic. For example, if you were asked to represent 1/3. Now again, this is very simple, right? You have to represent one part out of three parts. So what would you do? Using the logic as I discussed earlier, the distance from 0 to 1 on a number line, you divide it into three equal parts. Okay, so I have divided here and put these 2 points. Now when you begin to go from 0 to 1 and you come across these points, so the first point here is one part out of three parts. The second part is two parts out of three parts, and where we have one is three parts out of three parts, which is what I have shown over here. So 1 can be represented as 3/3. So in our case, if we want to locate 1/3 on the number line, we will just look at this point, highlight this point to say that this is 1/3 on the number line. So far, so good. Two simple examples. What if we are given 5/8? We can follow the same logic. The only thing is it might be a little bit complicated. So in this case, we have to represent 5 parts out of 8 parts. So what do? All you do is the distance from 0 to 1, you can see over here, this is 1, this one is 1. We divide this into 8 equal parts, and that is what I have done. So you can see as you go along these different parts, so you come across 1/8, 2/8. So this is 0/8, by the way. So 1/8, 2/8, 3/8, 4/8, and 5/8. So we would highlight this point over here on the number line to say 5/8, and you could actually use any of these. For example, if you are given represent 10/8, okay, this is a number which is in which the denominator is greater than the numerator. In this case, it's just bigger than 1. So you have to go all the way along, and this point will be 10/8. Now do remember, the one that I've shown over here can be written as 8/8. So how do we generalize this observation of representing rational numbers on a number line? Okay, so in general, for a rational number given, let's say a/b, the numerator tells how many parts you have to mark on the number line, and the denominator tells the number of parts into which unit is to be divided, in this case 1. Okay, that's what. So as again, going back to our definition of rational numbers exist between the numbers that we have already studied earlier. Like these numbers exist between 0, 1, 2, or between any two consecutive whole numbers or integers on a number line, right? So when you are given a/b, a rational number in the form of a/b, what you do is you find out what is b, and you divide a unit distance on the number line into B parts, which is what we did earlier, and then you locate A parts. Just go that small steps, and that will give you the location of A by B. Now, other interesting thing to note is you could also have a negative rational number. So if the sign here, in this case, it is a positive sign, which I have shown over here, this one, if it is positive sign, then we traverse or we go towards the right hand side of the number line, and if this sign is negative, then you travel onto the on the left hand side of the number line. So that is how you would represent rational numbers on a number line.